If set A contains the elements 1, 2 and 3, B contains the elements 3, 4 and C contains the elements 1, 3 and 5, we need to obtain the following. Okay, let us begin. So here we have three sets. So let's quickly note down each of the three sets. We have the set A containing 3 elements 1, 2 and 3. Next we have the set B containing the elements 3 and 4. And then we have the set C containing the elements 1, 3 and 5. So let's first try to compute the first part of the problem 1. Now, before computing the Cartesian product, let's try to find out the set B union C. So B union C, this is going to be simply, we'll consider all the elements that are common to both B and C first. So here we have the element 3 that's common to both B and C, and we're going to include the rest of the elements as well. So we have 1, 4 and 5 as well. So this is going to be the set B union C. Our next task is to obtain the Cartesian product of A and B union C. So A has got the elements 1, 2, 3. This is going to be forming a Cartesian product with the set B union C. B union C contains the elements 1, 3, 4 and 5. There are 4 elements in B union C. So what we'll do to find out the Cartesian product, we'll consider the first element of the first set. So order is very important here. The first set being A, we'll consider the element 1, and we're going to form an ordered pair with each of the 4 elements of B union C. So that means we are going to get the first ordered pair, which is 1, 1. Next ordered pair, that's going to be 1, 3. Third ordered pair, that's going to be 1, 4. The fourth ordered pair is going to be 1, 5. Fine. Next, we are going to pick up the second element of the set A, which is 2 here, and we're going to form an ordered pair with each of the 4 elements of the second set B union C. So that's going to give us 2, 1. Next, we have 2, 3. Then we have 2, 4, and then we have 2, 5. And then we have the third element of set A, which is 3, and we're going to form an ordered pair with the elements 1, 3, 4 and 5. So we have 3, 1. Then we have 3, 3. Next we have 3, 4. Next we have 3, 5. So this is the Cartesian product of the set, the Cartesian product of A with B union C. Okay, let's go to the second part. So we need to find out the Cartesian product of A with B intersection C. So before obtaining the Cartesian product we'll need to obtain the set B intersection C. Okay, so B intersection C is simply going to be the element that is common to both B as well as C. So we can see here that's the only element that is common to both B and C is 3. So B intersection C is going to be 3. Okay, now let's try to find out the Cartesian product of the set A containing the elements 1, 2 and 3 with the set B intersection C containing the element 3. Fine. So we're going to consider the first element of set A, which is 1, form an ordered pair with the element 3 of the set B intersection C. So that's going to give us 1, 3. Next, we're going to pick up the second element, which is 2, and form an ordered pair with the element 3 of the second set. And then finally, we have 3, 3. So this is going to be the Cartesian product of A and B intersection C. So let's go to the next problem. Here we need to find out the Cartesian product of A and B intersection with the Cartesian product of B and C. So we'll need to find out Cartesian product of A and B separately, and then also the Cartesian product of B and C separately. So let us begin. So Cartesian product of A and B will be simply take the elements of the set A 1, 2 and 3, form an ordered pair with each of the elements of the set B. So that will be 3, 4. So this is going to give us, we have 1, 3. The procedure remains the same. We have 1, 4. Next ordered pair is going to be 2, 3. And then we have 2, 4. And then we have 3, 3. And then we have 3, 4. Fine. Next, we will take the Cartesian product of the set B and C. So B has the elements 3, 4. We're going to form a Cartesian product with the set C containing the elements 1, 3 and 5. Fine. So that means we have 3, 1. Next we have 3, 3. And then we have 3, 5. Next we have 4, 1. We have 4, 3. And then we have 4, 5. So we'll finally find out the Cartesian product of A and B intersection with the Cartesian product of B and C. Now here we observed that the ordered pair 3, 3 is present in both of the two sets. So that means our Cartesian product, when we take the intersection of these two Cartesian product, that's going to give us one single ordered pair 3, 3, or we can say a single element which is the ordered pair 3, 3.